Hi, everyone. I'm really happy to be with you today. I'm Barbara Cohen from NASA Goddard. I'm introducing Jen Heldman, who is helping me design and implement potential future Artemis missions. And I wanted to talk to you today about some of the work that we've been doing on these potential future human missions to really drive out the process that Sarah just mentioned, which is how do we incorporate science at a much earlier stage in mission planning and make sure that the science that we want to do, our highest priority science, really permeates throughout the whole mission. And so we have been working, SEO has been working, Sarah and Joel and Brad and that whole office has been working on milestones for a big picture strategy for lunar science and for other areas of science across all of SMD on how we want to use the Artemis and future lunar missions to really make big progress on our big goals. So I'm happy to share with you the early stages of that planning today. Next slide, please. So just to recap, you'll hear about Artemis 2 and 3 later in the session, but just to recap sort of our biggest constraints for crewed lunar missions, we're going to assume that they're broadly similar to Artemis 3 in terms of their capabilities. Of course, you heard Jake and everyone say we're not 100% sure about what the exact elements will be, but in terms of capabilities, what we think we're going to be able to expect is South Polar landings, 6.5-day missions-ish, something like a week, multiple on-foot EVAs to conduct a surface geology field campaign, like you heard Lori say, walk back distance, maybe in some cases some mobility, and you heard Sarah say we're working on conditioned sample return, not just sample return, but sample collection, return, and curation to get down to lower temperatures. But in the early stages, we may not have that asset. So we're looking for things that we can do early in the campaign that are enabled by these kind of beginning capabilities. And then as we move out with bigger and better capabilities, trying to scope our science to take advantage of them as they come online. Next slide, please. So just to remind folks, we don't get to make up the missions ourselves. The science that we have in every Artemis mission and every future crewed lunar mission comes from you, the community, first and foremost. The community does an amazing job putting together guiding documents, not just for SMD, but for all the science that we do across NASA. We take that incredibly seriously, and you heard Sarah say that too. We often ask you for this guidance, and we're happy to tell you how it gets worked back into the planning that we do. So the decadal surveys, all of the ag reports from League and XMAG and all of the places that really put a lot of thought and time and effort into what you think the best science we can do is. Those get worked up into other documents like the Artemis 3 Science Definition Team Report, NASA's Moon to Mars objectives. Those all have direct traceability to your documents and your ideas and your priorities. Next slide, please. So those of you who know me know the science that I work on. I could not be more thrilled that SMD and its process has worked up the ideas, trying to mesh what ideas the community has with what opportunities we have with us. And we think this is going to be a big win, both for the crewed lunar missions and for the SMD community. We can use these missions to really focus on achieving our big picture goal for early basin chronology. Early lunar basin chronology, particularly the South Pole Aitken Basin, comes up again and again. It's been a feature in all 3 of our planetary decadal surveys that we've had to date. It comes up on New Frontiers missions. It comes up in directed mission recommendations, multiple community-generated documents. It's one of the SMD big picture challenges. So what we want to do is make sure that we're addressing those big picture challenges with the assets we have, and having crewed lunar missions to areas near or on the rim of the South Pole Aitken Basin can afford us a unique opportunity to really take a big bite out of that strategic lunar challenge. So investigating the formation, evolution, and age of the South Pole Aitken Basin to anchor lunar chronology and the lunar cataclysm and all the things that go along with it. It's not just solar system science, as this community well knows. It's a science goal for the whole solar system. The Artemis 3 exploration zones, and you'll hear about that more later. You've been participating in this definition of those all along. Those lie in the general vicinity of the rim of the South Pole Aitken Basin. But as we go forward and we're empowered to derive some of the landing sites, we are thinking about how we can use that process to get better at addressing South Pole Aitken Basin science, really trying to understand the stratigraphy of the SPA, its formation, its subsurface structure, its rim and interior, the materials that come from them, and how to best return those materials for the wealth of laboratory science on the Earth that they can give to us. The goals for something like an SPA sample return don't depend on cold conditioning, so they don't depend on these future capabilities that may come online later. Those future capabilities are going to be super, super important for other kinds of science, a lot of other big picture science like volatile samples, for example. Once we have cold condition samples, that's going to enable us to open up a whole new world of collecting and returning volatile samples. That is not going to be online necessarily for the earlier missions. And so how can we best take advantage of those capabilities to bring back unconditioned samples? And I just want to remind everyone, this isn't the only thing that we are able to do at the South Pole. You'll hear about all the great stuff that we're trying to accomplish with Artemis 3 in the South Polar region itself. The geology is super important, the lighting conditions, all of the resources. ESDMD even recognizes this. ESDMD has this white paper available online, the Why the Lunar South Polar Region. What's the science value? What's the exploration value? So taking advantage of all of these, they are even acknowledging that South Pole Aitken Basin is one of the main questions that we have across all of NASA. Next slide, please. So a campaign that focuses on early lunar basin chronology might have some of the following elements. Again, this is sort of very early planning, some thoughts that we have for how to focus the science that we want to do on a mission. But let me emphasize again, it's focus, not exclusionary. So we're just trying to give a focus to the overall kinds of flavors that we would think about in a campaign, along with all of the other great science that we would want to do. So of course, what is the age of SPA? This is one of the most enduring questions that we have in the lunar community. It's something a lot of people work really hard to understand. It's the oldest basin on the moon, the oldest stratigraphically recognizable basin on the moon. So it anchors our understanding of the bombardment history of the Earth-Moon system. Everything else is overwritten over top of that. So all of the other basins in the area, all of the craters in the area, add to the story after the formation of the SPA itself. Because it is such an important tie point, we want to understand when it formed. But that's a really complex question. It's not probably a single point in time. The basin formed, the basin was filled with melts, that melt probably differentiated. There's a lot of time questions associated with that. And in fact, there's no current consensus on what is the age of SPA or what even would we be looking for. And I'm just showing some examples here of a crater count age and two different sample ages, all of which purport to constrain the SPA basin age and all of which are not in full agreement with each other. And I'm not saying this is not ongoing work and really important work. I'm just saying it's a very complex question that's going to deserve a lot of attention, not just by a mission like this, but by a lot of missions. And identifying samples, returning them, identifying where they came from, the provenance, the basin itself, the substructure of the basin, and doing this in a statistically rigorous way is a tall order. Next slide, please. Like I just referred to, the South Pole Aitken Basin materials themselves are very complex. If there were a big melt sheet, likely thick melt sheet would probably differentiate, and then that material obviously gets moved around, worked into the regolith, scattered throughout the whole entire area. So it's almost certainly present at all of the Artemis 3 candidate sites in more greater or lesser degree. I know a lot of people in this community are working on where to find that material, how it gets mixed into those materials. And so judiciously selecting landing sites can really go a long way towards understanding how that material moved around and really targeting ways to bring some of that material home. Next slide. And finally, the formation of the basin itself, in addition to being an old basin that anchors our understanding of lunar bombardment history, it's the biggest basin on the moon. And so that makes it unique in a lot of ways to understand the impact process itself and how that affected the moon and how it would likely to affect other planets. So understanding the structure, the evolution, the geologic evolution of that basin, being on the rim itself is a really unique vantage point into the evolution and subsurface structure of a very large basin. Next slide. Okay, so I can't emphasize this enough. This is a focus, not an exclusion, and it's a part of addressing the strategic challenge. The strategic challenge of understanding the age and nature, composition, and evolution of the South Pole Aitken Basin is an enormously complex undertaking. It's going to take a whole community and multiple approaches. So this is just one approach. It's a big topic. We understand that Changi samples were returned and they got a date for those. There may be other sample return missions. They're all part of the big picture here and trying to understand what we're looking at. And Artemis 3 itself, some of that material is probably worked into the regolith. How are we going to recognize it? How are we going to bring our tools to bear on trying to pull apart those rake samples and find those samples? So all of these go into helping us refine an approach as we continue to develop things like the endurance mission concept and try to attack this problem from multiple angles. And I will say, too, that it doesn't solely rely on getting to the rim of SPA. The SPA material is worked all through the South Polar region. And so optimizing isn't the same as trying to be exactly on one spot. Next slide, please. All of the basins that we see at the South Pole, all of the craters we see, all of the stratigraphy is overwritten on the SPA itself. And so all of that goes into helping us understand the stratigraphy and the nature of early lunar solar system bombardment. So as we come up on future mission opportunities, I'm just going to emphasize one more time, this is a focus, not an exclusion. Responses are not limited or exclusive to early basin chronology, but things that can help us optimize our chances of achieving this big picture science or taking a big bite out of this big picture science are what we're really looking for. There's lots of other things to do with the poles. You know them, you love them. You're going to see them coming up in Artemis 2 and 3. Those are all still things that we want to achieve as well. We have an opportunity coming up for crewed handheld instruments. Those are things that may be able to help us characterize the environment, the geology, and samples to provide additional context. We're hoping to have geology teams and participating scientists competed, as you've seen before, trying to help us optimize that science, plus all the other good things that we want to do. And of course, our crewed lunar missions aren't serving exclusively lunar and planetary science. They're serving all of SMD, helio, biological and physical sciences, astronomy and astrophysics, or science. They all are going to want to have their own focus areas and things that they want to do with crewed missions too. So this isn't going to be even the only focus area for future lunar missions. So all of those go into the pot as we go along. Next slide, please. A couple words about the landing site process that Sarah alluded to. We do have an agency capability called the Cross Artemis Science Site Selection Analysis Team, or CASA team. They've come and talked at a lunar science surface science workshop before. They've talked to you directly about what they do. You'll hear some of the outputs of their work again today. So their job is really understanding how sites play with our assets that are going to be landing there. How do things achieve safe landing? How do they achieve landings that are conducive to having crew walk around on the surface, right? So that's lighting and thermal and hazards and things like that. Those are all super necessary, and they're going to constrain a lot of the landing sites. But now we're trying to get science into that process and get science as the first down select, right, or the first prioritization. So here's a prioritized list of sites. Now let's go vet those for their engineering properties. We don't know how far down the list we're going to need to get because those crewed landing sites are going to be constrained by the engineering needs. It's not going to be totally driven by science, but we want to get science into the process to help prioritize. So next slide, this is where we're really asking for your help as this community. So we are planning what we're calling a landing site workshop, but I want to be clear, it's not picking the landing sites for future lunar missions. It's picking figures of merit, or sorry, developing figures of merit. And what I mean by that are ways that we can vet or ways that we can assess landing sites or regions or areas for their science merit. Right now, focused on early lunar basin chronology, but in the future, this is a flexible process, and we'll be able to tweak it for whatever focus we want to do. That's a process that we want to use to prioritize potential landing areas or landing sites that the community agrees these are good figures of merit to be using. And then we can give those to the engineering teams, and they can use them to merge science with engineering. So we want to use our increasing capabilities. We want to optimize locations for the SPA structure and formation, and relevant materials can be found in return. Possibly ways that we can incorporate handheld instruments and techniques. How would they be useful? So those figures of merit are what we are asking the community to help us develop as we go forward. And we're going to have a landing site workshop. It's going to be an LSSW. We will invite abstracts where we will ask you to suggest your own figures of merit. And what that means is, instead of thinking about your favorite landing site or a landing site that you think would fulfill some of these goals, step back and think about why. Why would you suggest that site? Why would you select that site? Those are the figures of merit. You use them. We want to just make them explicit. So that's what we'll be developing at this workshop together. And I think last slide. Yep, so crewed lunar missions are a long-term sustained effort to address decadal survey objectives across the whole range of SMD. So maybe this isn't your science like it's my jam. Your science is coming up, I promise. This is a long-term sustained effort where we're going to be able to take big bites out of our strategic challenges across all of lunar and planetary science and all of the other areas of science that we serve. And I'll stop there. Thanks.